What's up, you guys? Today we're showing you a project where we're installing a 220 outlet inside the garage. Now, whether you're doing this in your shop or garage, it's going to be the same process. And this is becoming more and more common with the ramp of electric cars, and you need a place to charge said electric cars. So I called some reinforcements in for this one, and my buddy Joel Walsman from Indianapolis, Indiana, has a company called Jefferson Electric, and he's going to walk us through the complete process of how to install the outlet, whether you're doing this as a DIYer and you're taking on this project safely yourself, or if you're hiring it out and just want to get an idea how a pro would handle this so you are more informed. So let's jump into it.
Fun to be with you guys today. As my buddy Scott said, we're going to be installing a 220 volt outlet in the garage. And I'm going to walk you through the nuts and bolts, the do's and don'ts, materials, tools, everything that we employ to execute this project. Here in this particular situation, we've got 18 horizontal feet from the panel to the outlet that is going to be located between the garage doors. That's about 30 overall wire feet. First consideration at the electrical panel is, do I have the capacity, right? That's the number one question. Do I have the capacity, in this case, to add a 50 amp load, that's a continuous load, in the form of electric vehicle charging. So the cost of the project today, in materials alone, right off the shelf at any big box store, $450. The cost of copper in the last year has increased 300%. We don't know if it's going to stay there, if it's going to come back down. Hiring a pro is easily going to cost you another $500, $600, $700 on top of your materials, and going with a Tesla certified pro, a little bit more than that, and I'll tell you why. Now, as I'm pulling the last couple of bolts out of the electrical panel, I want to be mindful of safety. I'm using my left hand to brace the panel, so I'm securing it to the wall. I'm removing the last screw, and I am positioning myself with two free hands to pull the cover down safely. One, so it doesn't fall back into the live electricity, and two, so it doesn't swing or tip and shut off half the breakers in the house. I've done that before. So you're going to rock it off away from the work surface. Boom. All good. So in this case, we've got a 200 amp breaker. This is a 200 amp rated service, which is fantastic. Most 100 amp rated services are not going to have the available capacity in your average home to add a 50 amp continuous load for electric vehicle charging. Main incoming power is at the bottom. We've got 3/0 copper feeding a 200 amp breaker, and thankfully the available breaker space is at the top. This is a Square D QO panel. Finding a matching breaker for your panel, breaker panel compatibility is key. A quick Google search will reveal whether a breaker and panel are compatible. Here's our 50 amp breaker, real easy to pop it in there. I'm going to brace one hand on the wall so that I've got a framework essentially to keep me from shifting as I apply force to the breaker to snap it into place. Whew. Boom. Quite a bit of force is required. You may have noticed I did not turn off the main breaker when I installed the breaker at the top here. If you're a DIYer working at home, you probably do want to hit the main, because if one of your fingers slips back in there, man, it's could be ugly. And at this point, we're just about ready to start rocking and running our conduit across the surface of his garage. In this case, we'll be using electrical metallic tubing, known as EMT. This is also available at any hardware store. You may have walked past it, but a couple things I like about this. One, it has a good finished appearance, right? The industrial look is totally in style all over America. You can't go wrong. You could also use PVC conduit. And you also have both rigid and flexible applications. In this case, because I'm a pro, we're going to try to be doing it in the most professional manner while using regular DIY tools and materials. So these 90s, these are purchased pre-bent, so you don't have to use an electrical conduit bender. And these fittings apply with nothing but the use of a screwdriver. So let me show you now a quick overview of our wiring path and give you a little insight as to why. So overview for this is we're starting at the main electrical panel, breaker panel. We're going to be fishing the wire up the wall so you can see what's happening there. And then we're going to utilize surface conduit because above the garage here, this is living space. So fishing a wire through the framing, almost non-feasible. We're talking about drywall, repairs, etc. Not going there for this. We're going to be utilizing surface conduit from the top of the wall, around the perimeter, following the blue tape lines, and bringing it all the way down to 44 inches above slab between the garage doors. For an electric vehicle charging outlet, that's probably the most popular consumer choice for where to place an outlet, because a standard 18-foot cord, like you would get with the Tesla wall connector, the Tesla mobile connector, is going to reach to charge both vehicles, whichever garage bay they park in, and that's going to be common with most of your EVs, Nissan, Volt, etc. So that's a perfect placement. One install, two vehicles. Parts. Now if you're a DIYer, this might look a little bit intimidating. You might not have worked with most of these parts before, but we want to share everything we've got here so that you can be the most successful and maybe keep this project down to 2 trips or less. Starting sequentially at the electrical panel, we have a 2-pole 50 amp breaker. Don't let the half-size handle fool you in this case, because see, there are 2 terminals and 2 connection points to the bus. This is most definitely a 220 volt breaker. Now let me dispel one myth real quick. 220, 240, which is it? Same? Different? It's the same. That's the ticket right there. The voltage system has always been a nominal voltage. Back quite a long time ago, it was a 110, 220 volt grid. The grid has run hotter slowly over time, and now it's a 120, 240 volt grid. That is the nominal voltage. And in our area, the grid actually even runs hotter than that. You'll test typically 246 volts. So is it a 220 volt outlet, a 240? Answer is yes, they're the same thing. Moving away from the panel, we're going to be utilizing EMT, electrical metallic tubing. The first fitting is our LLR. That is the proper name of this fitting. It is a convertible LL or LR. If you hold it like a gun and the cover's on the left side, that's an LL, L for left. If you hold it like a gun and the cover's on the right, that's an LR. This is a convertible, and the compartment is for wiring access. There's no way you could ever pull the wire through that bend. It's impossible. So you have to remove the cover to create the wiring path and maintain accessibility. Now these are conduit fittings here. We've got store-bought pre-made 90s. That's probably what you're going to be utilizing so that you don't have to purchase a $40 conduit bender. These are conduit straps for securing and supporting the conduit. This type is a mini. A mini is handy in that, as we'll show you, there's an intentional half-inch offset between the wall and the conduit, and that's going to come in handy in Scott's project. This is a 1-hole EMT strap. It's a rigid strap, provides 1 mounting hole. Here we've got set screw, couplings, and connectors. When you're shopping, make sure your connectors come with the lock nuts. Sometimes those fall off in the bin. You get all the way home and guess what? You're one tiny part short. Here we've utilized a deep 4-inch square junction box. 4-inch square is the diameter in each direction, and buy the deepest one you can. This one is 2 inches, and that is to accommodate the depth of our receptacle. In order to mount the receptacle to the box, we will be utilizing a plaster ring, which is good for 2 purposes. This is a 1/2-inch plaster ring that fits a 4-square box. The plastering is going to allow the proper mounting hole configuration, matches up to the receptacle, and it also adds a little extra depth to accommodate wiring. Finally, we've got the plate and the NEMA 1450 receptacle. Now this is an industrial version, which I highly recommend. If you're going to be plugging in a $50,000 appliance, your electric vehicle, to a receptacle and it's going to experience almost daily wear and tear, you want to purchase one that's of a good quality and a matching plate. Be warned, the NEMA 1450 is exactly the one you want for electric vehicle charging. There are a lot of other 50 amp receptacles with similar but different configurations. Make sure you grab the right one. That's a lot coming at you right there. If I were you, I'd probably pause, take a screenshot for your shopping trip to the store. In the description, we're going to include a complete material list with links to make your shopping easier. For this project, we're utilizing 6'3" Romex or non-metallic cable. The Romex is equipped with two hots, a neutral, and a ground, each one matching up to a specific terminal on your NEMA 1450 outlet. Romex is the standard wiring method for residences, and it's going to be one of your most cost-effective wiring methods. So right now, this is where I would prefer to start the project. The other end is a little simpler, but this is more important, and it's going to bring definition to what other elements look like. And I've got a couple pro tips for you also. So firstly, I'm working in a live panel. If you're a DIYer, I suggest you kill the main. In this case, and this is a slightly older panel, there are exposed live terminals down here. Not so concerned about the ground and neutral bars here, but man, these mains coming in, they will get you, so watch out. Terminals down the sides also, these live terminals at each breaker, there's a sting there too waiting to happen. So we're gonna route our wiring out of the panel in a code compliant way, fish it up the wall if at all possible. We'll be utilizing a fish tape to check the wall to make sure we're coming out at the right spot and we've got a clear wiring path before we commit by cutting a hole in the drywall. So I'm selecting a 3/4 inch knockout from the top of the panel. The congestion of wiring is right here in the center, so I'm intentionally going to the right of that because our wiring path is off to the right. I'm also being considerate about my bending radius. That's the radius of the 90 to make sure that conduit body plus 90 can actually make this turn here, and I've got plenty of space in this installation. But if your panel was closer to the wall, you could get jammed up. So I've got my large flathead screwdriver, my pliers, and I just gotta go to work on this knockout back and forth until I've removed it. There's the 1/2 inch. Gotta take it a bit further to get that 3/4 inch knockout. And let me tell you, sometimes, it can be a beater. They're in there so tight. Your needle nose pliers may be a help to you. In this case, I've got a small pair of linemen's. Gives me a lot of leverage, a lot of grab, and I'm just gonna go back and forth nice and easy until I get it out. All right, so I'm gonna be utilizing a fish tape to plunge the wall, and here's the pro tip. The fish tape has an intentional hook on the end, which is fantastic, but I'm gonna tape that hook because right now, when I send the fish tape up and pull it back out to get a depth and clearance on the wall, I don't want it to get snagged. I've had to cut off too many fish tapes that have gotten lodged in the wall. Here we go. Ooh. All right, so this is the wall between the garage and the house. So there is insulation in that wall. So I'm gonna take the natural bend of the fish tape, I'm gonna bring it toward me, and I'm gonna try to slide it up on the outside of the insulation along the drywall to avoid having to fight the batt insulation the whole way. All right, right there's a definite stop. So I'm gonna mark the location, I'm gonna pull it out, I'm trying to put my eyes and ears on the end of the fish tape, so I'm feeling for obstructions, making sure I've got a clear wiring path, and now I'm gonna lay it alongside the wiring path to see if I've got full, and it looks like I do. Look at that, I probably stopped right at the top plate of this wall. Now that we're pretty certain we have a clear wiring path up the wall, we're ready to cut the drywall and start running conduit around the perimeter. Okay, so a quick trial fit on parts here. The 90 is gonna sit right in the corner. I've got my conduit body that needs to align with the stud cavity above the panel. And remember, I'm intentionally to the right of my main wiring trunk here. So I've got clearance, and that's gonna be a nice fit. All right, we're ready to cut our hole, and I'm gonna bring it down just a little bit because when they hung the drywall, there was reveal on the top plate. So if I cut my hole right at the very top of the wall, I'm gonna hit wood. I already know that based upon common construction standards. So I'm gonna bring it down at least 1.5 inches. And I like that right there. I'm using a keyhole saw, and I'm doing that on purpose rather than a power tool because I wanna have a very sensitive touch, because I know that the wall is full of wiring, and the last thing, the absolute worst thing that you could do on this project, besides blowing up your Tesla, is you cut into the wiring that's in the wall. That could turn into a multi-$1,000 repair. So you wanna have a touch on what's happening, you wanna feel it. All right, I've got a clear path. Now that I know that's where I'm going with it, I'm gonna go ahead and mark the wall. Actually, don't have. All right, so in this case, I'm a lazy electrician. I'm using a flathead screwdriver to mark the wall. I do that all the time. It's just incredibly practical, and I've always got a flathead screwdriver. All right, now before pulling any wire, I generally complete my conduit system. Let me show you a couple things. One is this little gem didn't get called out in the parts list. And what this is a chase nipple. This is going to smooth the threaded edge of my conduit body. And I'm just gonna put it right in there so that when my wiring is exiting the conduit body, it has smooth exit, because houses do vibrate, and believe it or not, something that's been fine for a long, long time can go bad in the dead of night. So that is code to protect wiring during the installation. One thing that I'm being mindful of as I plan my conduit right here is that I've got these vertical supports on either side of the garage door. Those are actually gonna accommodate our effort. The minis are gonna have almost that exact amount of standoff, so I'm gonna use straps on my wood supports and obviously get a really solid connection. And I'm gonna use minis and drywall anchors on my drywall. Code is that within conduit bodies and junctions, I need to have a support on the conduit system within 3 feet. All right. So, taking my measurements, utilizing my old school folding rule, never falls out of my pocket. See, the master electrician that I trained under started his career in 1966. So I got a little old school and homespun in me, no doubt. But this is fiberglass. It's very lightweight, it's more cost effective than most tape measures, and it's incredibly manageable with one hand. So I measured to the wall from my conduit body. I came up with an overall dimension of 13. I've got to subtract for the radius of my elbow, which is 7, and I need a 1/2 inch off the wall so I can accommodate the framing uprights. So 13 less 7 is 6. Then I'm going to deduct another 1/2, and I'm at 5.5. So my cut dimension is 5.5. One thing you've got is a little bit of grace. The conduit fittings themselves have a 3/4 inch depth. As long as I've got enough meat for a solid connection with the set screw, that's going to be sufficient. Now, I see a lot of people fighting the hacksaw. If you've not done this and it's your first time, my best advice for you is 2 things. One, I'm going to cut over my bucket because I'm an electrician and that's what we do. You probably have a better surface, but the trick is to hold the conduit really, really firm. If it's moving around, you're doing nothing but fighting it. And the second is to realize that the teeth on your hacksaw are oriented so that you're doing the cutting on the downstroke, not the upstroke. The upstroke will just fight you if you try to get any work done. Just plunge and you'll be much more effective. So I've got a firm hand on bucket and conduit. I've got almost my full weight on that knee. And I'm just gonna get it started with the edge of my finger. And once it's in the groove, I clamp and cut. It's important to realize that the factory parts have already been reamed, but it is a code requirement to ream your cuts, both inside and out. There are a lot of specialty tools for it, but man, a large flathead screwdriver, any steel edge, run around that is really going to clean it up. Get rid of the burrs. On the outside, the burrs will prevent your fittings from seating. On the inside, that could cut into your wire. I always stick my finger in there. If it's good for your skin, it's good for the wire. All right, at this point, I'm running my conduit around the perimeter of the room. One of the marks of an electrician is that you're gonna orient all of your screws on your fittings in the same direction. That's just little marks of professionalism. And when those marks aren't there, home inspectors, city inspectors all get a little bit more suspicious and your work starts getting scrutinized unnecessarily. Okay, looks like that's gonna fit. Now I'm gonna run conduit around the perimeter and down to the box where the outlet's located. And then I'll double back and give you some tips and codes around how to do that best. Two pro tips, real quick. Another thing that this is absolutely perfect for. This is a folding rule and it fits right up inside the conduit fitting so that I'm getting a true measurement of the conduit length and not an outside measurement that needs to be adjusted for conduit length. Now here, I'm mounting the box 44 inches off the garage floor. That's an incredibly standard electrical measurement to the bottom of electrical devices. And in this case, I've got a 69-inch measurement to the mark that I've laid on the wall. It's actually 69.25. I'm going to deduct 4 inches for the width of the electrical box. And then, here's the pro tip. I'm going to deduct another 1/4 inch because I'm going to lose a little bit on the shoulder of the fitting and I don't have to be absolutely full depth. I'm going to give myself a little bit of grace, that 1/4 inch of play that'll really, by the time I deduct for the shoulder, have about an 1/8 inch of play. Now this is very important. When you're using a metallic conduit system, the conduit itself is actually part of the grounding system. So you want to make sure that every set screw, or if you have a compression type, every compression ring is snug so that the electrical conduit would never become energized but would be properly grounded. There it is. All right, so what I do is I always stop a 1/4 turn shy of final destination. Final destination is set screw straight out to match everything else we've done. And I'm going to use my adjustable pliers and bring it around. And if you recall, every metallic to metallic connection is part of the grounding system. So I'm very intentional about getting that lock nut on there securely. That's the easiest way to do it. So what we've selected here is a metallic threaded drywall anchor. These things have a lot of holding power. I'm intentionally utilizing 4 anchors for the receptacle because there's a lot of force on that receptacle going in, but particularly coming out, and the risk is pulling the box out of the wall. So this metallic anchor is going to give a pretty decent amount of grab. You can pilot the holes. Well, and really why I've done that is I wanted to identify the location when the box was in place and I had the level on it. So now I've got a clear target. Anchor flush to the wall, a little thrust from the palm to get it going. So behind the box here, we did hit a stud, and turns out it's quite a bit of force and effort to use one of the anchors into the stud, so we're just going to use a screw direct. The goal is to properly and securely fasten the conduit. It's not to close the gap, so that gap is intentional. Last thing we're going to do is check all of our set screws as we move back along the conduit to make sure everything's secure. Box is mounted. Before we advance to pulling and terminating the wire, if you've enjoyed this so far and you're a DIYer with a stack of projects, or you're looking to get into the trade and we do need more good tradespeople, please check the description for Electric Pro Academy. That's where we're posting multiple videos per week to help you advance your electrical skill set. All right, now we're ready to pull and terminate the wire. This is kind of the culmination of the project before we do final testing to make sure we don't blow anything up. I'm going to remove this conduit body from the system. It's not bad to go ahead and put it in place because then I have a start point for all of my conduit system. I really don't want to piecemeal it, but I've got to get it out of the way so I can optimize my ability, whoops, lost a screw, so I can optimize my ability to manage the fish from the electrical panel to my drywall access point. So at this point, I'm going to fish the wire in 2 stages. I've got the wire placed over there, and that's simply because I don't want to have to pull all the wire through here and around. It's too cumbersome. I only want to pull the necessary length of wire through my most challenging and tightest portions of the project. The only thing I don't like about having the fish tape over here is that I've got to be incredibly careful with the fish tape on the electrical panel for safety. Straighten it up just a little bit. I'm encountering enough resistance that what I'm going to do is go ahead and get my gauge on the fish tape again so I know how much fish tape needs to be inside the wall in order to reach my access point. I'm going to put a little flag right there. Oops. That's my identifier. Let's go. Give it a shot. So my flag indicates that my fish tape is probably all the way up the wall. I'm going to do what I can with my fingers and oh my goodness, it's right there. All right, but let's pretend that this was a little harder. What you can do is just use a scrap of wire, bend a hook on it, and now you've got a fishing apparatus to get inside the wall and to grab the end of that fish tape. I also happen to have these little beauties right here. Look at that. Pistol grip, triple hinging needle nose pliers. You can get an incredible distance inside a very tight hole, and because it's pistol grip, you've got a good line of sight into a very small hole. In this case, whew, nice and easy. No arcing in the panel. We're there. So I have 2 fish tapes, so the luxury of sending them both in and doing the pull in 2 stages. If you only have 1 fish tape, I recommend that you start with this pull. And the reason for that is you want to pull all the wire through the longest run and only the last 8 or 10 feet through the fished holes where it gets a little bit more complicated. Let's look at the other end. Okay, so here's something that even my apprentices don't always do, right? The wire comes in this tight bundle, and if all that twist is in it when you're pulling it through the conduit, then there's so much more resistance. So what I always do, and I preach day and night, is pull the wire out and give it a clockwise twist to straighten it out, and it's just going to pull that much more smoothly. So if you've been an electrician for any length of time, you know that one of the most frustrating things is to have your wire pop off partway through the pull and have to reset. So what we're doing here is we're going to take the bare copper conductor, which has plenty of strength to sustain this pull. I'm going to give it a pretty hard bend through the eye of my fish tape. And then I'm going to take the other conductors. And there's a little bit more I could do if this was going to be a really hard pull. I could stagger the cut on these conductors. For instance, cut the white here, cut the red there, and leave the black full length so I kind of ease the transition and the head of this pull. I could also lube the wire. There's a dedicated electrical compounds for that so that the wire insulation and integrity is not damaged. But in this case, I'm really not concerned about that. The conduit is properly sized. That's 3/4 inch EMT for the 6.3 Romex. No concerns there. I am using decent electrical tape. This is Scotch like 88 is real good. And I'm pulling it tight. Can't use really too much. So this is the end result. It's a really smooth pull. It shouldn't have any issues. If there are going to be issues, it's going to be right here at the head where the fittings are, not midway through the pipe, but right at the fittings. If you run into an issue when you're pulling, stop, pull it back. If you can, give it a twist and then continue on, and you'll almost always get through. If you end up yanking really hard, sometimes the head will come undone, but this head is, man, you can apply 200 pounds and you're good to go. If there's ever a time to employ or enlist a friend to help you out, this would be it. One person feeding the wire into the conduit and the other pulling the fish tape. Remove this fitting. So at this point, there's enough friction in the pole, every coupling, every connector, every 90, even the length of pipe, that you electricians out there are going to call me on it. Because conduit systems are supposed to be complete before the insertion of wire. But we're going to ease our resistance. We're going to get the pole complete. I do have help on the other end. And next time, I'm just going to advise you, go ahead and lube it up. Really grease that sucker down. Here it comes. All right, 8 more feet. So that was part 1 of our pole. Here's part 2. We're going to be inserting the conduit body. The worst thing is to finish the pole and realize you missed a piece, right? Oh, I totally have done that before. So inserting the conduit body. So guys, this was harder than I thought it would be. Next time, instead of using an LL or an LR, dude, I totally use an LB. And that's where the back, the cover, is opposite the feeder hole. That's really gonna ease things for you. If you're sweating like I am, take a break, grab some water. But I wanted to highlight 2 things. One is make sure you have your sequence of parts in the correct order. And 2 is this pro tip. This is like the #1 code violation in all panels, many panels across America, is that people are feeding wire through the panel without a protective connector to both provide strain relief and protection against the sharp metal edge. So in this case, before we secure our wire, we're going to slip it on in the proper orientation to the outside of our cable. And I want about 3 feet of cable inside the panel. So I'm gonna go ahead and secure it right before I pass it through the hole, about 3 feet from the end. Hold it up there for a fit. A little bit further. I don't want to have too much excess cable in the wall because that's just hard to manage. But also I can't have the fitting come up short. I do need it to seat in the top of the panel. And I have got the lock nut to secure it. All right, now that my connector is through and I've got a good smooth bushed opening with strain relief for the wire, I'm sliding my lock nut on and I'm gonna maintain just a little tension on my wire, and I can pull it back to the panel to get the connector to straighten up and then slip it on there. Whoop. There it is. That's the trickiest part right there. That is a pro job. If you get that connector in place and you get it snugged up and it's a good tight fit in a code compliant way, that is a pro job. That's the difference between hiring an electrician and a handyman. That's the difference between getting flagged by an inspector and having a good, clean completion. This final bit is a beast. Getting all the wire and fittings seated pretty in the wall, and then doing a little fit and finish on my conduit pole. The pole was hard enough that the conduit did shift. That's fine. We're just gonna shift it back, put a level on it, and make sure it's sharp. At this point, I'm going to terminate wire at the box. I like to use a utility knife. I'm going to retract the blade a little bit on purpose. And if you have a real light hand, no rush, very low pressure, you're going to find that you're not going to damage the inside insulation. The outside insulation is a little softer. See, I haven't even cut all the way through. That's totally fine. I'm going to rip it open, peel it back, expose the inside conductors, and cut off the excess. I have a smaller pair of pliers on me, so I've actually stripped the conductor back a little bit further on purpose, and I'm going to cut the individual conductors at least 6 inches from the face of the box. See, I want enough working length. I want some extra in case I goof something up, but definitely not too much extra, because this wire is really going to fight me getting it back inside the box. There's 1, there's 2, 3, 4. I'm going to cut them all the same length. I'm going to strip 3/4 of an inch. Here's something to think about. Most strippers, and my strippers, don't go up to 6 gauge stranded wire. I'm going to use this 6 gauge solid stripper, and I'm not going to pinch it all the way down. I'm going to ring it around the insulation. I don't want to score the copper conductors. Real slow, gentle touch. And then when it's almost all the way through, peel it off. You can feel the difference between the insulation and the copper. And then right there at the end, just pop it off. Remove the insulating paper around the ground. At this point, we're going to terminate the receptacle. We're going to orient the receptacle with the ground on top on purpose. The right angle cord is going to hang down. It's going to dress nicely to the wall. If I invert it, the cord is going to have this perpetual awkward strain and a weird look to it. So I want to think about that as I'm terminating and orienting. Start with the ground. It's a number 2 square drive. If you're using a Phillip, you might find it's not a real great fit for this. Large flathead would also be a decent instrument. I'm going to check each connection visually and with the tug test to make sure it's fully seated. I'm not going to put the death grip on these screws because I'm actually going to torque them at the end. And that's actually a point right there. If you're using a Tesla certified electrician, he's probably going to be equipped with a torque screwdriver like this, which is where he's actually seating every terminal to the proper torque, 25 inch-pounds. You see how this terminal is silver or white in contrast to the brass and the green? Well, this is the the neutral terminal. I want to make sure that my strip gauge is good, so I'm not getting any insulation to impede the connection. I'm going to tighten it down, and at this point, I'm going to wiggle to seat and tighten the stranded conductors. I'm going to tighten, I'm going to wiggle. I can feel the difference every time I wiggle that terminal loosens up a little bit. I'm going to seat it. I'm going to allow the stranded terminals to mesh, and it allows for a higher conductivity connection. That is a pro tip. There's a massive differentiator. If I don't do that, what's going to happen is this outlet is going to get a substantial amount of heat stress. Totally normal. Those conductors are going to expand and contract, and you're going to end up with a loose connection. You're going to come back and just not understand. You put the death grip on it, it's torqued, and now it's loose. You've got to seat the stranded conductors. Little tighten and wiggle, 2 or 3 iterations. Now I'm going to land the 2 hots, red and black. They're interchangeable. Tighten, wiggle, tighten, wiggle, visual inspection, tug test. I'm going to get them all seated. I'm going to torque it down. At this point, I'm landing the receptacle in the box. Install the plaster ring, and now I'm seating the receptacle itself. There's quite a bit of resistance on those wires, forcing that receptacle out of the box. That's why I really recommend the deep box with the plaster ring, also called a mud ring, and just crank it down with the 4 screws. Make sure none of the conductors in the box are up against a sharp edge. We've terminated the receptacle, landed the plates on, neatly finished. Now we're going to go back to the electrical panel. We're going to land the breaker and button it up. So at this point, we're going to land the conductors in the panel. This is the most dangerous part. Note, the only way to kill all power to this panel is to have the utility company pull the meter outside. Shutting off this breaker only kills power from here up. If you're a DIYer doing this project, you're really going to want to terminate power. It takes nothing but just a loose ground conductor tapping a hot terminal to really cause stuff to fly. So here we are, lacing in our grounding conductor, and I'm going to bring it down the side of the panel. I'm going to tuck it in alongside those wires. I bent a smooth 90. It doesn't have to be real sharp. In fact, it should not be real sharp. There's such a thing as wire bending radius, that if you bend copper wire too hard, you will cause it damage. So I'm going to lay it in there. I'm going to put my thumb exactly where I want it to be cut. I'm going to cut off the excess. I'm going to keep it from bouncing into the panel. If you're a professional, the panel's live. That's your prerogative. And then, because all of the top, most forward-facing terminals are occupied and most of them are double tapped, we've got to sneak in, and it's a little laborious to get these back terminals. So I'm going to pull my existing conductors out and out of the way. I'm going to lay my new conductor into the panel. All right, at this point, needle nose, because of the congestion of this panel, needle nose are going to come in real handy. There, it's seated. That's a number 2 square drive. I'm going to snug it, not death grip, and move on to my next conductor. My grounded conductor, or neutral. Same process. I'm getting it laid in there exactly where I want it. My thumb marks the cut. I'm going to take it real easy so I don't score the copper conductors. And now I'm going to lace it in there, same fashion. That is tight. So we've just terminated this grounding and this grounded conductor right here. We snuck them in, wires 1, 2. And I want to call your attention that this ground and neutral bar are common with this ground and neutral bar on this side. That's not always the case. Sometimes grounds and neutrals must be separated by code. And so The general rule of thumb for a DIYer is follow what's existing in the panel, but be mindful that the separation of grounds and neutrals may be a requirement. Next step is we're going to terminate the hots, black and red. They are being used interchangeably, and some people will put a service loop up in the panel. At this point, the panel is full enough. I don't want to create any more congestion, so I am going to not put a service loop, but I will leave as much excess as possible. If I had to, I could pull a tighter angle on that. So I've got my length marked on my first conductor. About 3/4 of an inch. There is a strip gauge on the breaker itself. I'm going to give it, actually, see that? A little outward twist. And that, because of these wires, is going to help me tremendously come in at the right angle. One thing to note is that the breaker terminals are in the tightened position. So you're really going to struggle if you don't realize that. You've got to loosen the breaker terminals, but take it easy. Nothing worse than losing a screw down inside a breaker panel. Circuit breaker is in the off position right now. Got it seated. I like it. At this point, the installation is complete. We're ready to rock. I always look away when I turn a breaker on, just in case there's a fault or a failure somewhere. Hand to breaker, face averted, we're live. I'm going to highly recommend that you use some kind of test equipment. In this case, we're using AC voltage to test our circuit, and you can pick up test tools for as little as 10, 12 bucks. I'm going to fix my lead, and first I'm going to check hot to neutral, 125 volts, perfect. Second hot to neutral, 125.3. Hot to hot, 250. So you see, this is a 120, 240 volt distribution system. That's a nominal voltage. It is running hot, not in a bad way, but this is reading 250 volts. So more appropriately, in this case, it's a 125, 250 volt. So we've just verified voltage at the electrical panel. We're seeing exactly what we want to see. We've tested here at the receptacle, hot to neutral and ground to make sure nothing's been reversed. It looks great. I invite you, if you have questions, codes, best practices, comment below. We want to engage with you and help you out with your particular situation. And then I know, rightfully so, that working in the electrical panel can be really intimidating for DIYers. So check out this video right here, and I'm going to show you the 5 most common electrical panel mistakes that I've seen in the last 15 years. I want to help keep your home safe, you safe, and your project on track.